see so many people here. Obviously, there's a really keen interest in the community around this topic. So, and before I launch into this, it's probably also just worth saying that, I think what several of the speakers have sort of said is that there's a real need for more information and to find ways to get all the data that we collectively have kind of out there in a meaningful way. And I think like Mark's tool for Plant ID is a great example of that. And certainly as an academic, it's a great thing to have the opportunity to get to collaborate with agencies like DPAW in doing this sort of work, as well as some of the firework that I'm involved with. Okay. So, I'm talking today about my PhD student, Pavel Verisak's PhD project. And this was throughout the whole way in collaboration with DPAW. And this is kind of what fieldwork made him do. But by December of last year, he was a much happier man. But he's left us now, and he's stylishly enjoying life in New Orleans. So you're stuck with me instead. All right. So what I'm talking to you about today really is this idea of how do we restore Banksia woodland. And obviously, I don't need to go into any great detail to tell you about how it's a threatened ecological community, and this sort of the backstory of how offsets are ongoing. And so, of course, many of you would know. So offsets, when those are employed, you can either maybe protect existing Banksia woodland that's not already reserved, or identify places that are degraded and try to manage threats. And so that's what we're talking about today, is parts of the conservation estate that were degraded and were identified as needing some sort of intervention. And as Mark was already sort of talking about, the topsoil is definitely this biological resource. And this time in which we live, as the city's expanding, land is being converted, that soil seed bank that sits in that topsoil is potentially a really valuable resource that could be translocated when the land is converted and then put in a site to then hopefully restore it. And again, as Mark was sort of referring to in his talk, there are a huge swag of species in this community, and I think Greg said the same, that really we don't have great knowledge, technical capacity to propagate or to return to sites once they're lost. And that topsoil is potentially the resource, that legacy that we can impart to a degraded site. But the question then becomes, it's pretty bloody expensive to move the stuff, right? So if we're going to move it, what are we going to do? What's the best way to try to make that happen? Okay. So how much should you lay down? Should you rip it? Should you apply something crazy like smoke water or heat? And I should say, when we started this project, we were actually talking with Mark about getting this going. We suggested that they burn the airport before they cleared it. And I got this sort of scared look from Mark, like, oh no, it's an airport, you can't do that. They won't like that. So we did think about that. But it did become a question of, well, what should we do? And our research group had been involved with a smaller offset with respect to the Fiona Stanley Hospital when that was constructed. And so we looked at some topsoil transfer in that. And one of the things that had come out of that was we were really interested in the fact that when the topsoil is stripped, and you can sort of see pictures here of that kind of happening. When that's happened, so you knock down the vegetation, and then sometimes some of the remnant vegetation might be mulched, and certainly you're going to have a lot of leaf litter and stuff, and then it's going to be stripped to some depth. In this case, it was about 7 or 8 centimeters. Using this device here, they basically welded a plate on that would sort of keep the front end loader at a certain depth. And when that happened, it's going to change the soil structure clearly, but it's also going to impart a lot more fines into the soil. And when we did the Fiona Stanley stuff, we thought that there seemed to be some pretty good evidence that there was more compaction. The soil had kind of gotten pretty dense, and so we were quite interested in the issues around how much depth, and do we need to rip it to try to break up that soil. And of course, we know a lot about topsoil handling from a mining context. Alcoa have done a lot of research. Kings Park team working the sand mine north of Perth have also learned quite a bit. This is a slightly different context in the sense that the whole soil profile hasn't necessarily been turned over. You're just taking the topsoil and then putting it on top of a relatively undisturbed profile. So that was kind of the context in which we found ourselves. So what we kind of wanted to do is we set out to try to say, okay, we've got these recipient sites identified. Here are some potential treatments that we could think about. Let's see what happens once the topsoil is down, what's going to germinate, and then how's that survival going to look over the first couple of years. And so I think Mark already flashed up a picture of these, but so the Jandakot offset was 150 or 165 hectares. Within that, a subset was cleared, and then I think it was about 19 hectares, is that right? Yeah, about 19 hectares of recipient sites were identified. One sort of group at Forestdale Lake, another group along Anketel Road. Okay, so what do we do? So essentially, we set up basically a fully factorial design where we wanted to look at soil depth, which was basically 5 or 10 centimeters depth, ripping or not ripped or not ripped, and then fenced or not fenced to try to understand, what role either rabbits or kangaroos might be playing in those early stages. And so each of the squares that you can see here basically represent a large 13 by 13 square meter area. And within that, we had smaller 2 meter by 2 meter subplots in which, why Pavel wanted to do headstands, is he and our research technician, Billy, basically spent long days with their heads lower than their asses, counting tiny little plants in the spring and the autumn. And we started, the topsoil was stripped in April of 13, 12? 13. 12, okay. It's so long ago now. So it's stripped in the autumn, and then pretty much moved over by May. And then we put in the plots, installed those through the winter, and then the monitoring started in the spring, that following spring, and then through the following autumn, the next spring, and the following autumn. So the data that I have to share with you today basically are 2 years worth, two complete annual cycles. Okay. Also, kind of along with those sort of site scale stuff, Pavel tried to experiment a little bit around, well, can we enhance germination anyway? Can we hit it with smoke water or try a heat treatment to see if that might enhance germination? And as well, he just did a little bit of weed control. The first year, we noticed a lot of those sort of rosette type of weeds like Hypocurus and Arctotheca and stuff were starting to come up, and Erodium. So he hit those with a little bit of herbicide to see if that would have an effect. And I can tell you, which basically Mark kind of already alluded to, that we basically found very little evidence of an effect. And at the same time, Will Fowler, who's doing his honors then, now is doing his PhD on mapping or looking at Banksia woodland condition, basically found that where these two circles are, that if you took soil from the site after it was moved, put it in the glass house and germinated it, and then took that same soil and treated it with heat or smoke, you basically had no enhanced germination. So that scarification of the seeds through the process of transferring the soil had basically caused them to germinate, and you weren't going to get any more bang for your buck out of that. Now, the only slight caveat to that is Pavel went out a year after, so a full year and a bit after the soil had been transferred, scraped a little bit back, and then did a heat treatment. That actually did boost germination a little bit. So basically, if you wait and the seeds kind of go back into a dormant stage, and then you hit it again, there is some suggestion that you could get a little bit more. Okay, so what did we find? So what you're looking at here is the germination. These are perennial native plants, and this is in the first year. Okay, and what you see is each of the panels is divided into the soil ripping treatment, the soil depth, and then whether it's fenced or not, and the y-axis is sort of a log transform plant density with means and confidence intervals. And so the main thing to notice here is that you can see the unripped and deep groups had higher densities of germinants in that first year. Okay. If we move over to annuals, so these would be things like Trachymene or any of all the Asteraceae sort of native annual sort of things. You can see they're reasonably consistent across those treatments, except you'll note that the unripped group is higher, and notably, the ripped group is lower. Okay. So if we then, that's the first spring, and then if I give you a much more busy and hard to look at figure, you can see again the perennials are red and the annuals are green, and again you can see that same scale, and now we've got years 1 and 2, and you can sort of basically see that if you sort of scan across that from left to right, you can see that the unripped group is sort of sitting there a little bit higher, and then you can sort of see an annual decline of those red dots from year 1 to year 2. Those means are moving down because the germination was much higher in the first year than in the second year for perennials. But importantly, not zero. So what sort of effect do we see overall for germination? That fencing had very little effect on germination. That should not be a surprise. You put the dirt in a truck, you dump the truck, you smooth the dirt. The seeds don't care if there's a rabbit around or not, as long as they persisted long enough for us to see it and record it. Was there an effect of ripping? Yes. It was negative. So you can imagine, same scenario, but now before you have a chance to germinate, basically tractor drives by, ripping the soil. That had some sort of negative effect on the germination process for those seeds, either by just physical burial, by tilling the soil down to, I believe it's 50 centimeters, and bringing up subsoil that did not even have seeds in it, just that physical issue, or somehow impeding the germination. Okay? So for perennials and annuals, that ripping had a negative effect on germination. Okay? Depth was equivocal, so whether we had 10 centimeters or 5 centimeters depth, there didn't seem to be a huge thing. And like I've already pointed out, there was a strong year effect, but importantly, germination still was occurring in the second year. Okay? So for many of you in the room, you'd be accustomed to thinking about how these places work in relation to fire. So if fire happens, seed bank goes crazy, you have a bunch of recruitment, and even by the second year, you're not going to see very much germination. In this instance, not so much. Still a big pulse, but still a substantial amount of germination in that second spring. So there was still a lot of biological value to be had in that second year. So that definitely tells you that if you were monitoring or planning, you'd want to be assuming you'd be getting germinants recruiting into the pool for a couple of years. Okay. Now how about survival? That was germination. Now this is a little bit more complex. So let's sort of deal with the effect of time first. So if we look at from the first autumn to the second autumn, so what we did, as I already told you, we monitored these things spring and autumn for 2 years. And so that gave us the ability to measure the disappearance of things over those 2 summers. Okay? So if we recorded it in the spring, then it disappeared in the summer, over the summer, it died. So in both years, not surprisingly, we had survival differences between the years. That has to do with the first summer was probably more benign, had fewer heat waves, had a rain event in December, probably kept things kicking along. And you also see in this that the blue circle is the deep ripped versus the deep unripped. Okay? So interestingly, you see in 3 of those 4 groups that there's a bit of a difference there. And so that the deep unripped group, at least in 3 of the 4 cases, had slightly higher survival. Okay? So again, in this instance, the ripping seems to be associated with, on balance, lower survival. Okay. Now overall, when we look at across both years, you see the effect is consistent. Okay. So that basically the deep ripped group is lower than the unripped, and also that those two deep groups has slightly higher survival than the shallow soil. So how does that kind of work out? So that the overall, for survival, you have a negative effect of ripping the soil. There's a slight positive effect of soil depth. So basically, more topsoil equals higher survival rates. There was a clear year effect. And I sort of, conveniently glossed over the fencing effect, but that it interacted with year. Okay, so where does this put us after 2 years? Essentially, we see that deep groups and unripped groups had greater final densities of plants. Okay, so that's about, thank you. This is per square meter, and I was trying to quickly do the math in my head as Mark was talking, and that would, at a per hectare basis, that'd be about, for those two groups that are high, that's about 3,500 per hectare, which is half of the target that Mark had on his slide, I think. Did you have 7,000? Yep, okay. And so basically, long story short, the deep or the unripped groups had higher final outcome. So what's that mean then? Well, for all of our, gee whiz, let's do this awesome fully factorial design, I think it's given us, in this instance, some interesting evidence that putting a little bit more topsoil, and once the topsoil is placed, no longer manipulating it through ripping, seem to come up with the best outcome. Fencing in this system was equivocal in terms of its results. Clearly, that is a site-based issue, depending on where you're working. There were clear year effects. Again, that's not surprising in this environment. And down the track, as Pavel, he's busy revising his thesis right now for the final thing, and then his chapters will appear as publications hopefully in the next year or so. And we'll be looking at functional composition, and then you'll be hearing about longer time frames. So, thank you very much.